Hi everyone, this is Carlos with the Emacs Science Support Team. Today we are going to be looking at MulensModels, a microlensing event fitting tool. So this tool is really awesome, and if you go and click on the download button, that will take you to their GitHub repository where you can scroll down to examples, and here they have a bunch of examples for us to use, and we're going to keep it simple, so we will be doing the MulensModel tutorial.ipynb. But they also have the option to do some planet grid fitting as well as many other things. So going to the notebook, here it is, the Introduction to MulensModels. So again, this is for gravitational microlensing, which if you don't know, gravitational microlensing is when one star goes in front of the other and it creates this magnification event, as you can see here. And in this example, there is a planet crossing the first star, the star in front, and that will create this big spike in light because light is being magnified, and this can be a planet. So going back over to our tutorial, first thing we're going to do is we will import our packages. Then what we are going to do is we will define a point lens model to use. So to define a point lens model to use, there's three big parameters that will be really important to us. So that's T0, mu0, and TE. So T0 is the time of the closest approach between the source and the lens. Mu0 is the impact parameter between the source and the lens, center of mass, and TE is the Einstein crossing time. So PSPL is a point source point lens model, and then 1S2L is one source two lens model. So we have one model here and we have our second model here. Because this one has two lenses, there is some other variables that we need to worry about. Those being rho, which is the radius of the source as a fraction of the Einstein ring, Q, the mass ratio between the lens companion and the lens, and alpha, the angle between the source trajectory and the binary axis. In all these tutorials, they have all of these variables that we need to define, and if you need help figuring out what those are, you can go to their paper where they list all of them, and that paper can be found by clicking the ADS button. So back over to our tutorial. So we have defined our two models and we want to see what those look like. But before we do that, for the 1S2L model, we are going to set the magnification method to this VBBL. VBBL is the BOSA's approach, which is awesome because it allows for error control, which allows the user to set a threshold for the precision and magnification of the calculation. And in simpler terms, that means you can be more efficient with your computer. So coming on down, we can actually plot these models. So to plot these models, it's really easy. All you're going to do is use this .plot underscore magnification. You will give it your time. So this is where we expect the event to happen. Here, all we're doing is zooming in on our time scale. So as you can see here, the red dotted line is the point source point lens, which we would expect to be a nice smooth curve because we're saying that in our fake data, we just have two stars crossing each other. So now in this black line, we have our one source, two lenses. You can see that spike we were talking about. This might be caused by a planet, but there's also other causes that could be doing this. Suppose you had some data for yourself that you wanted to import. So we have the OGLE data and we have the MOA data, and we want to go ahead and import that. So to import that, you would just find where the data is and then pull up your files, and these files all come with the MulensModel package. Here we are just reading in that data. So now using the 1S2L model, we are going to combine our data sets and plot them all together. To do that, you will set my event to MulensModel.event, and with this .event option, you can set your data sets to our two data sets from above, and of course set your model to this right here. Now, to actually make the plot, we will use my events.plot underscore model. Again, give it a time range. Set this to true, a color of your choice. Then down here, you'll do the same thing. But now you will say data reference is equal to 1, and S is equal to 5, where S is the, come on down here to their paper, the projected separation between the lens primary and its companion. Cool, super useful. Then you can go ahead and plot, and this is pretty cool right here. Mulen's model automatically fits for the source and blend flux of the given model. Just as easy as that. And here is our data plotted on the 1S2L model. Now if you want to know if this is a good fit, all you have to do is use this dot format my events dot get chi2 chi squared, run it, and that is our fit. Easy as that, guys. So that is Mulen's models. Hope you guys enjoyed this tutorial. Super useful tool, and yeah, have fun. Peace.